Okay, so today's job is we have to change the oil filters. There's two of them in this 2-circuit low temperature. Another challenge is we can only shut off one circuit at a time because this is a production machine. So we're going to do circuit 1 first. This whole line that I'm pointing to goes to a heat exchanger that's filled with oil. So we can't just recover what's in this line because our recovery machine will not recover oil. So here's the plan. We're going to use the push-pull method. We're going to use our recovery machine and pull some suction gas out of that circuit, pump it through our recovery machine at a higher pressure. I've got some junky gauges that I use for this, but the hoses are clean. We come out of this yellow hose and we go into the top of that oil circuit. The bottom of this oil circuit, we're going to go through another set of gauges, and these gauges have a sight glass. We're going to start pushing oil, and you're going to see oil flow through that sight glass, coming out of the suction hose, which is normally your suction hose, and back into the top of this oil separator. So we're not recovering any refrigerant, we're not pulling any oil out, we're simply displacing the oil with refrigerant, and then we can pull the refrigerant and put it back in the same system. So no recovery tanks needed. So this sight glass is now filled with oil. It's kind of hard to tell, but pretty soon we'll see the oil go away and it get replaced with refrigerant. And actually you're seeing that right now. We're pushing all the oil out of the circuit that we're going to be working on through these gauges and replacing it with clear refrigerant. Once that happens, we'll get the refrigerant out next. And the oil is starting to dissipate. That foam you see is just a remainder of the oil mixed with refrigerant vapor. So now that we've gotten all the oil out of the system, it's now under about 200 something PSI of vapor. We've got to get that vapor refrigerant out so that we can open up the system down here at the oil canister and change that filter. So now we're going to recover this refrigerant out of this section by isolating with isolation valves that are already in place, and we're going to put it back into the same circuit here in the liquid line. So we're pulling gas off of this yellow hose, goes into our gauges, out of the blue hose, comes into our recovery machine, out of the recovery machine, and back into the liquid line. Again, we're recovering it out of a section of the chiller and putting it in a different section of the chiller that's isolated from each other. And since it's impossible to get all the oil out of this system that we've got isolated, we're pulling off of the top of that section of the circuit that we're working on. That way we have a minimal chance of pulling in any oil into our recovery machine. If we were pulling off the bottom, there would be a very big chance of us pulling oil into our recovery machine doing damage. But here off the top, it's never given us any trouble in the past. All right, we've gotten all the pressure out of these lines, and I got my hoses that are connected to them open. The reason why I'm doing that is that the isolation valves like that one and some of the other ones that I'm using leak by just a little bit. And so if we don't leave a place for this piping section to be vented, we're just going to build up pressure, and any pressure over about 1 or 2 PSI when you're trying to deal with oil will just spray it everywhere. So even 5 PSI will make an absolute mess. So I'm avoiding that by leaving these open, and of course we're going to pull a vacuum when we're done, so we'll get all the air out. All right, so we're using this wrench on that nut right there to back that whole oil canister out. And that frost that you see is a little bit of liquid refrigerant that's boiling off. When we do that, oil is going to start dripping out of it because this is the lowest point in the system, and we're going to catch it in that little catch can. All right, so here's what the inside of the canister looks like. You've got a filter element in there, and we've got some oil still in there with some refrigerant that's bubbling out. It's boiling off. We're going to replace this oil filter element. We're also going to replace these O-rings every time so they don't leak, get everything cleaned up. We're also going to pay attention to what that filter looks like, and if there's any pieces of metal material that's in the bottom of that canister, indicating we may have some metal on metal friction and wear that we need to be concerned about. All right, so here's the old filter, and here's the new filter. We'll stick that back in the canister, change the O-rings, get everything cleaned up, put a little nylon on the surfaces here, the threading surfaces, and get this put back together. Alright, so as you can see, we ended up losing a lot of oil from this system. Oh, and the reason why it's green is because a few years ago we had to put some dye in the system. And I think my technician put a little bit too much dye in the system to find that leak. So, anyway, so the point is we're going to have to replace some of this oil so that our system doesn't run low on oil. Now, we could fill the oil canister back up with oil. That's a very sloppy way of doing it. I'm going to show you a little bit better way. And if you have a better way, please, by all means, comment below. Alright, so here is the can of oil that we're going to add from. This is Solest 170. It's a POE oil. It's what's recommended by the manufacturer. Again, with POE oils, you got to be very careful about letting moisture getting into them, because once they get moisture, they don't release the moisture, and then you've got moisture in the system from that point on. So one of the ways we can add oil to the system is to use a hand pump or an electric pump. I keep a hand pump on the truck for these kind of situations. What I'm going to do this time is very quickly pull the system to a vacuum and pull that oil in with the vacuum using a hose, and then pull it on down even further to get any air or any kind of moisture that we've got in the system out. There's not a perfect way of doing it. Again, if you have a better way, by all means comment below, and I would love to learn from you. So here's what I came up with. I took the little seal that normally comes with that oil, drilled a hole in it big enough to get my hose through, and then I'll pack around the middle here with like a rubber glove or something, just to keep that as airtight as possible. Anything we can do to keep the ambient moisture out of this oil is going to help us. Alright, so we got a vacuum pulled on the system. We got oil in it before we did that. One thing about this system, as I mentioned before, is that some of the isolation valves leak by. So we're not going to be able to pull a 500 micron vacuum. We just got to do the best we can. Now I've opened up all my isolation valves, and the unit is ready to crank up on this circuit now. Alright, this is the first of two sight glasses that we're looking at here. This is your oil return sight glass. It goes back up to the screw compressor. This solenoid opens up whenever the compressor energizes, and discharge pressure pushes this oil back into the compressor. And we want to see a lot of oil in that sight glass. If we're low on oil, you'll start seeing a bunch of foam in that sight glass, and that's not good. In this case, this is normal oil flow through that sight glass. It's never going to be completely clear. The second sight glass is our oil reservoir sight glass. And this should always show about 1/4 to half full, which it is right now. It'll only show that level when the compressor is running. So we did get enough oil put back in the system, but we could have gotten away with getting a little bit more. For now, I'm just going to leave it as is because it's enough. And we're also going to observe some of the pressures and temperatures of circuit 1 before we leave it running and shut down circuit 2. If there's any issues with circuit 1, we're not going to switch it over to circuit 1 until we fix those issues, because this chiller has to remain running on at least one circuit. So our compressor 1 suction and discharge numbers are normal. We've got 20 degrees of subcooling. It's going to float around there. The other thing that we look at is circuit 1 discharge temperature. We're going to observe that for a little bit and make sure that the oil is cooling the compressor good enough to keep that oil temperature under 180 degrees. So at 180 degrees, a solenoid energizes that allows our oil cooler circuit to start cooling the oil down. As you can see, it's going to drop the oil temperature down to around 160, and then when it gets back up to 180, it'll cool it back down again. And this oil cooler circuit is what we've been working on. This is just a simple refrigeration circuit that pulls a small liquid line from the system liquid line, passes it through a TXV, goes in this brazed plate heat exchanger, cools the oil down. The cool oil goes to the compressor. The return suction gets tied back up to the suction line to return to the compressor. So it's a little mini refrigeration cycle inside this bigger refrigeration cycle that cools the oil down. All right, so that was circuit 1. That took about 2 hours. I'm going to grab a little lunch, come back, do circuit 2, and that'll be a wrap.